Hello class, it's Mr. Kablan here again, and today I will be talking about exponents, and it's just going to be an introductory lesson in terms of what exponents are and how we can put it in our calculator to simplify exponents. So let's get right to it. So if you have your calculator handy, you might want to just have it just for reference because there are a couple of keys on your calculator that I want you just to locate. And even though people may have different calculators, okay, I will guide you through how you can find where the exponent key might be on your calculator. All right, so when we're dealing with exponents, the key thing we want to do first is to understand where our exponent key is in our calculator. Now, depending on what maker your calculator is, I have a sharp one as an example because it's like one that I commonly use, is that if you find a key here and you have a y and there's a little x at the top right hand corner, okay, this is y to the exponent x. And I know in some calculators it's expressed as x to the exponent y, and in some calculators it's actually expressed as a hat type of structure like this. So if you have that key there, okay, that in some calculators that is the exponent key, okay, and the way you input it is exactly the same as how I'm going to express it in a few minutes over here. So if I wanted to express an expression with an exponent, okay, what you want to do here again is the follow the instruction, and then you can try it on your own calculator to see if it works for you. Otherwise, if you have a calculator that's completely different, okay, then you can speak to me after, and I'll show you how to do it on your calculator. So for example, if I want to evaluate or simplify 2 to the exponent 3, I would input it exactly in this manner here. So step number 1, okay, you press 2, okay, and then you press the y to the exponent x key or the little hat key if you have a calculator. I think Texas Instruments has that symbol there, okay, and you press 3. Okay, and your calculator now knows that this is 2 to the exponent 3, and then press equals. Okay, and when you do that, you should get an answer of 8. Okay, so that's basically the exponent key, and you'll be using exponent key quite often in this course here. So again, just know where it is. Now, what we want to do here is to understand some of the terminology that deals with exponents over here. And basically what we have here, as you can see on the screen, okay, is a physically big number, which in this case here is 3, and a little tiny number in the top right-hand corner there, which in this case here is 7. Now, this big number here, this big 3, this is what's called the base. Okay, now what the base is, again, is the number that's going to multiply itself the number of times that is dictated by the exponent. Okay, so that's the 7. So what does this all mean here? Well, basically in this example here, the exponent 7 will tell the base of 3 to multiply itself 7 times. For example, 3 times 3 times 3 times 3 times 3 times 3 times 3. Okay, that's what that means there. Now, the entire thing over here, this is what's called a power. Now, it depends what part of the world you are. This expression can be expressed as 3 to the exponent 7, and in some countries they say 3 to the power of 7. Either way, it's exact same thing. All right, now, as I said before, when you're dealing with powers here, the exponent tells the base how many times to multiply itself. So, for example, the example I used at the beginning of this lesson was 2 to the exponent 3. What that really is, that really involves is taking the 2 and multiplying itself 3 times. Now, please do not confuse this with 2 times 3. Okay, in this case here, this is taking number 2 and multiplying it 3 times, or 2 times 2 times 2, which gives us 8, whereas 2 times 3 gives us 6. All right, now anytime you have a fraction as a base, the key thing that you're going to see here is that all you need to remember is you need to multiply both the numerator or the top number and the denominator or the bottom number by that exponent. Now, again, I will show you in class using a calculator how you can actually just do it from there. Okay, but for the time being, we'll deal with how it evaluates itself, how it simplifies itself to both the numerator and the denominator. Okay, so for example, if I had 2 over 3 in brackets raised to the exponent 4, what this is really happening here is that the 2 will be raised to the exponent 4, and the 3 will be raised to the exponent 4. Okay, and you treat those separately. And that will give us an answer there of 16 over 81. Now, again, in class, I'll show you in your calculator how you can do it from the first step over here and how you can get to the final step all in one step there. Okay? All right, so let's take a look at exponents here and how to express them in different ways. So the first thing we're going to do here is to identify the base, and then from there, take the base and write it in what's called expanded form based on the exponent, okay? Now, the key thing, the key way to remember the base, okay, it's basically the easiest way to remember it is it's the number that's attached to the exponent. Okay, so for example, for the first question here, you notice that the 2 is attached to the 5. So in this case here, the base here is 2 because the 2 is what's attached to the exponent of 5 in this case. Now what that means here is that that 2 is going to multiply itself 5 times there. All right. And from there, that's going to be 2 times 2 times 2 times 2 times 2, which gives me 32. All right. Now, when you have a negative base inside the brackets, okay, whatever is inside the brackets automatically becomes the base. So when we have -3 in brackets, that's going to be the base here. Now, that's going to be very, very important because you notice that, for examples C and D there, okay, we'll talk about the importance of understanding why we need to know what's inside the brackets is always the base. Now, when we take that base of -3, you're going to rewrite that -3 4 times, okay? Now, just a little bit of a heads up when it comes to exponents and negative bases or negative numbers within a set of brackets. Anytime you have an even number as an exponent and you have a negative as a base, your resulting answer will always be positive. Okay, so if you, for example, have any even exponent, 2, 4, 6, 8, etc., and what you have there is a negative number inside the bracket, your resulting answer will be positive. Okay, if your base is a negative and your integer is odd, for example, 1, 3, 5, 7, 9, etc., then your answer will always be negative. Okay, so that's just a little bit of a shortcut. Okay, and from there, when you multiply -3 4 times, that resulting answer will be 81. Okay, now if you take a look at C and D, notice they kind of look the same. People will think it's the same question, but indeed it's not. Now, I'm about to show you why. So if you look at example C, notice that -2, okay, is inside the brackets and it's raised to the exponent 4. Okay, and for part D, you have -2 raised to the exponent 4 without the brackets. And you're probably wondering, well, what's the difference between the two? Well, the difference comes in the first step, which is identifying the base. So remember that anytime you have a negative number inside of a set of brackets, that automatically becomes the base. Okay, so the base for part C here is -2. So that means I'm going to take the -2, multiply it itself 4 times there, which would give me a positive answer here of 16. Okay, now I also said at the beginning of this particular example is that any number that's attached to the exponent automatically becomes a base. This comes in this is a very important step, especially when you're dealing with negative numbers without brackets. So for part D, for example, notice that 2, not -2, okay, is attached to the exponent. So the base of part D is not -2, but it's 2. Now, the way you have to understand that is that when you rewrite the next step as an expanded form, you're going to take the 2, and that's going to multiply itself 4 times, okay, and the negative goes in front. Okay, now you notice I've written down the 2 4 times there without the x's. It's just another way, a form of writing it. It's actually a cleaner way of expressing it. And you notice the negatives in front instead of brackets there. So if you take the 2's over here, 2 times 2 times 2 times 2 gives me 16, and the negative comes in front here. So the answer of -2 to the exponent 4 without the brackets is going to be -16. All right. So you might want to put a star beside those two examples because, again, anytime you deal with negative numbers, okay, you can see the importance of having brackets. All right. Okay, so in this case here, we were given a power and we have to expand it and then evaluate it. So for the next example here, the last example, okay, we have a fraction here. So the base here again is the fraction itself of 3/4. So for this case over here, when we expand it, we have to write the fraction of 3/4 3 times. And when we actually get to evaluate it, okay, don't forget the way you do this is to take the top number numerator and raise it to that exponent, which in this case here is 3. Okay, and you take the 4 and raise it to exponent 3 as well, which gives me 27/64. All right, that's pretty much it. All right, so we've looked at how we can take a power, expand it, and evaluate it. So for the next set of examples over here, okay, we're now going to go backwards, so to speak, by taking the expanded form, okay, and changing it into a power. Okay, so for part A over here, notice what we have here is 3 has multiplied itself 5 times. So the way we do this is to identify the base, which is in this case here the repeating number, which is 3, and how many times it's been multiplied by itself. So in this case, there's 5. So when we express this here, this will be 3 to the exponent 5. Okay, that's pretty much it. So if you take a look at B over here, okay, notice what we have here is 4 times 4. So since 4 is a repeating number, that will be the base. And since it's been multiplied by itself twice, it's going to be an exponent of 2. So what we have here is 4 squared. All right. Now put a star beside 13 over here because, again, quite often people will think, well, I don't see an exponent there, therefore the exponent is 0, okay, which isn't true. In this case over here, what we have here is 13. Okay, now you have to ask yourself, well, how many times does 13 multiply itself? Well, notice there's only one 13 there. So that we express that as a power over here is just 13 to the exponent 1, okay? Now you're probably wondering what 13 to the exponent 0 is. Well, if you punch that in your calculator, 13 to the exponent 0, okay, is 1, okay? That's just something we're going to cover later on, but I know people are asking that, so I'm just answering it now, all right? Okay, so that wraps up the introduction to exponents. You can continue working on in the package there. All right, and I will see you in the next lesson.